Today we're going to go over the indefinite integral. So basically, in the last video, we talked about approximating area by squares, by Riemann sums. But there's a much more efficient way to calculate the area of a function. And so that is through an integral. It's another word for an integral is an antiderivative. And here is the equation for an indefinite integral. So basically, it's an integration symbol, an integrand, which is the function, and then the variable of integration. So basically, you want to go backwards from the derivative in order to find the integral of something. So that's why when you find the integral of lowercase f of x dx, it's going to be f of x plus c. And the reason why there's a plus c is because that is a constant of integration. For example, say that we have the derivative f of x plus c. So let me go to my notes here. We're going to do that later. So say we have the equation f of x plus c. We say we were going to find the derivative of that. It would be f lowercase f. And then since this is a c, it would go away. That's why when you go backwards from to find the integral of f of x dx, that's why you would always add a plus c for an indefinite integral. We're not going to be talking about the definite integral in this video, but just for now, remember that it's very important for indefinite integrals. And what I mean by indefinite is that there are no numbers here and here. I'll explain later. Moving on. Okay, so how I said an integral is an antiderivative, you're basically working backwards. So we're going to do some example problems here to find the following integral. And for this video, I'm actually going to use a table to explain what I mean. Let me actually go here first. Okay. So we're only going to focus on the basic forms now. Okay. So we want to find the integral of 1 of x or 1 dx. So that's a constant. So if we were working backwards, what would give us 1? Well, the derivative of x is 1, right? So that would mean that the integral of 1 in this case is going to be x plus c. Okay, moving on. Actually, let me just prove that real quick. So say we were going to find the derivative of x. The derivative of x plus c is 1. Okay. So now we're going to go here. Think about it this way. What is the derivative that causes this to be 2x? It would be x squared. I mean, the integral of 2x would be x squared plus c. Okay. Now, we have the integral of 3x squared dx. So let's look at the first equation on the basic forms. Number 1, the integral of x to the n dx is equal to 1 over n plus 1 times x to the n plus 1. So let's just plug in values. Oh, also, there is a rule for this. You can take out the constant. So then you can rewrite it in terms like this. then you can just focus on this part and find the integral from there and multiply the 3 in the end. Okay, so following this equation, we have 3 times 1 over n. In this case, n is going to be 2. 2 plus 1, x to the 2 plus 1. Then if I add this together, we would get 3 over 3 x to the 3, or just x to the 3 plus c. And the plus c is in each of this. There'd be a plus c here, and there'd be a plus c here. Okay, so the final answer is going to be x cubed plus c. Okay, now try to do this problem on your own. Okay, so I'm gonna go ahead and do this problem right now. You can do integration by parts here. Or you can separate each like term and integrate from there. This is dx, dx, dx. Okay. Okay. So I went ahead and did this on my own, and now I can explain what I did. So let me just go ahead and look up an integral table so I can explain that there are some rules to this. I'm not just like pulling things out from my head. Okay, here's a table of integrals that you can use. But basically, I really just used the first equation here in the table of basic integration. So what I did was I separated each term and then isolated that and found the integral in each single term. Then I simplified it further to get my final result, which would have been 5 over 3 x cubed minus 4x squared plus 5 plus c. Okay, and the reason why there's a plus c is because it's not defined. In a defined integral, you need to, basically the c goes away because you can solve for the c. But since we don't really know like any set number, since it's in an infinite bound, we need to add a plus c. Okay, so I think that's all for today. I'm probably going to talk about the definite integral in the next video. Yeah. Okay, so this is really important. I believe this is also on chapter 3.1, the last chapter in your derivatives textbook. So it would be here. So you can go ahead and take a look at this. Antiderivatives and integrals are basically the same thing. Here's the definition of the indefinite integral. here are some rules. These are the rules that I used in the video. Sorry I was very not specific in this video. But yeah, just go ahead and take a look at this. See the connection between derivatives and antiderivatives. They are connected hand in hand. And then do some practice problems. Do your best. It's really not that bad, I promise you. It's actually a lot nicer. Like if you know derivatives very well, then integrals are gonna transfer over very nicely. So anyways, thank you for watching. I'll see you guys in the next video. Bye.